Good day everyone. This is Alex Chu from IDEC. In today's tutorial, we are going to see how to display distance measurement data from SE2L at different locations on our HG touchscreen. Okay. In previous tutorial, we have shown you guys how to display distance measurement data at left hand side of the screen. And in this tutorial, we are going to do something different. Okay, to relocate the whole radar, okay, from left hand side to any other location on the HG touchscreen. In today's example, we are going to use the sample program generated in the previous tutorial. If you are keen to know how to create this sample program, you may follow the step-by-step tutorial in our YouTube channel. And the result of that tutorial is going to be this program, which will display the distance measurement data of SE2L at the left hand side of the touchscreen. So now I'm going to show you a few modifications in this sample program in order to bring the distance measurement data from SE2L to any other location on this HG touchscreen. So basically, the modification will only be done in the script with script ID number 103, which is the script in charge of drawing straight line. In previous tutorial, we have learned that the SE2L radar that display on HG touchscreen is actually consists of many lines, which is drawn and in charge by this script with ID 103. And in terms of why the SE2L radar always appear at the left hand side of the screen, right? It is actually determined by the originated point of the line. Okay, so if you look into detail of this script 103, you will notice that all the lines drawn is actually originated from a coordinate with coordinate x 260, coordinate y 300. Okay, so all of them is actually drawn. The line is extended from this point. Okay, 260 for coordinate x and 300 for coordinate y. So you can see that. So it is very clear that if, let's say, we would like to relocate this radar from the original location with center point through 260, 300, we can do it as simple as changing this coordinate. All right, so let us see how we can do that in this tutorial. All right, before I proceed to modify this sample program to allow flexible changes of this center point of the radar, I would like to briefly explain two topics. Okay, the first topic is the coordinate system of our HG touchscreen. All right, and the second topic is the drawing line function of the script. Okay, so let us understand the coordinate system of the HG touchscreen first. So just now we talked about the originated point of the line drawn on the screen. Okay, for our sample program is x coordinate is 260, y coordinate is 300. So this 260 and 300, where is the reference for this coordinate? So actually the reference is located at the top left of the screen. So the top left of the screen is having a coordinate of 0, 0 over here. So x coordinate is 260, so it is somewhere around here, 260, okay? And y coordinate of 300 is somewhere around here. So how do we know? How can we know? So for our HG 3G or HG 4G touchscreen, all of them is having a resolution of 1027 times 768. So that means the width of the screen is actually having 1024 pixels. Okay, whereas the height of the screen is having 768 pixels. So this point is 0, 0, and this point is 1024, 768. Okay, so you can imagine just now, if let's say x coordinate is 260, so it should be somewhere around here, and the y coordinate is 300, it should be somewhere around here, so which give you the center point of the radar somewhere in this location. Regarding the second topic, which is the line function, drawing a line on the screen by using script. Okay, so you can see that we are using a lot of line function in our script, okay, which draw a line for each angle of our SE2L. Okay, so a very simple property of this line function is that whatever line is drawn on the screen, it will stay there permanently. So how can we update the length of the line for each angle of distance measurement? So basically, we just for simple understanding, if let's say the line stay permanently over there, in order to change the length of the line drawn, we have to erase the line first and draw a new line with different length. So how do we achieve that in script 103? Actually, we are getting a help of a rectangle. Okay, so to give you an example, in this script, actually, let's say for angle 0, we are drawing a line of 100 mm long, for example. Okay, and at the next scanning, probably the length changed to 50 mm. Okay, so in order to shorten the length of the line, first of all, we have already draw a white color line of 100 mm, and then we make use of this rectangle function. We draw a rectangle with black color, okay, which will cover up the white color line of 100 mm. So it looks like the line has been erased, and then the next cycle we will draw a line of 50 mm at the same location. So when we play this, when we repeat this step in a very high frequency to the user or to the viewer of the screen, it looks like the length of the line is changing dynamically. So this is how this is the working principle behind this script. In this sample program that we took from previous tutorial, so this is the characteristic of the rectangle drawn on the screen. So if you would like to know in detail what is the meaning of each of these number, you can go to this rectangle function, and these are the description. So this 60 is actually the x coordinate of the starting point of the rectangle. 100 is the starting point y. Whereas 459, this is the endpoint x, 479 is the endpoint y. Whereas all this, the rest of the number is actually the characteristic of the rest of the characteristic for the rectangle. For example, the line width of the frame, the color of the frame, the color of the background, and so on. Okay, right. So okay, you can see that actually this is pretty small. This rectangle is pretty small, 60, 100, 400, 400. So you should be somewhere around here only. Okay, all right. So because we are going to change the radar from left hand side to any other location, we should make our rectangle as big as possible. So I would suggest to change the starting point of the rectangle to 0, 0, and then the end point of the rectangle to somewhere around here. Okay, if you refer to the coordinate x and y here, let us take a round number. So it should be let's say 1000 for x coordinate and 500 for y coordinate. Okay, let us do a quick change. Okay, so it should be 0, 0 for starting point, should be 0, 0. Okay, for end point of the rectangle, 1000 for x coordinate, 500 okay for y coordinate. Okay, the rest, the color, the line width, and so on, we don't need to change anything. Okay, so other than changing the rectangle size, we also would like to make the center point of the radar flexibly modifiable. Okay, let us replace this coordinate. Instead of using a fixed coordinate, we replace it with a data register in the task screen. Okay, so for the x coordinate, let us change all the 260 to LDR0. Okay, so you can see that we use a lot of 260 in this script. So how can we change it quickly? We can actually make use of this replace function again. Okay, 260, change all of them to LDR0. Okay, and yes to all. Okay, let us double check. So we should find out all of them has already been changed. Nothing weird happened. Okay, nothing weird. All of them has already been changed. Okay, so the same thing we need to, same modification we would like to do to the y coordinate. But please take note this 300 y coordinate. So when using replace, it will be a bit tricky because if you filter 300, it will also affect those 300 hiding inside the let's say LKR address 0300. Okay, so I would suggest when you do this, if let's say you notice the 300 is actually surrounded by some other element, please include them as much as possible. Okay, so that it will not mistakenly replace those addresses in this script also. Okay, so for example, this 300, I would like to change it to LDR0002. Okay, right, so change all of them. Yes. Okay, let's take a quick look to make sure nothing weird happened. So all the 300, okay, this has already been changed. Okay, I think I have forgotten the comma sign for this LDR0002, but no worries. Let's repeat the same procedure again. Replace bracket LDR0002 with comma LDR0002 bracket comma again. Okay, place all of them. So now it should revert back to normal. Okay, let's see, nothing weird, right? And other than this, this 300 shall be changed also. Okay, again, we can verify. Okay, you can either repeat the same step again just now by using space 300 space, replace it with LDR0002. This is one way. Or you can try to use match case or find whole words only. If you do not know what does it mean, you can have a try. Okay, by using this find instead of replace. Let us use find to verify the conditions. If let's say I use match case, we will see that it will also consider the 300 hiding inside this address, this memory address. But if let's say we find whole words only, okay, you can see that it will only focus on this 300. So let us repeat the same thing again under replacement function with this find whole words only checked. Okay, replace what 300, replace by LDR0002, check this find whole words only, and then replace all of them. Okay, now double check again. Yeah, all of them has been successfully replaced. Okay, without any funny or weird thing happen. Okay, that's great. All right, the modification since has been done successfully. All right, with x coordinate is equivalent to the value inside LDR0, while y coordinate is equivalent to the value inside LDR2. Okay, let us put this numerical input on our screen. Okay, so don't forget, just now in script 103. So all the memory address here is actually unsigned 32 bits. Okay, so when we place this numerical input box on the screen, there shall be unsigned 32 bits as well. Okay, and if let's say this is x coordinate, then it shall be LDR 0. Okay, right, and then let us duplicate this box for y coordinate. Right, y coordinate shall be 2. Okay, so let us also include some text so the user know this is for x coordinate. Okay, use window. Okay, so that the font size, everything can be changed very easily. 12 x coordinate. Okay, this is y coordinate. Right, that's it. Let's save it and download it to our touchscreen to have a try. See how it works. Alright, the download has been successful. Okay, so let us access the touchscreen by using our web browser. Okay, right, start scanning. Okay, before drawing this radar, let us initialize the value first. 260, 300. Okay, and then start scanning. Alright, you can see that now the radar is appearing at this location with the center point of the radar is 260 for x coordinate and 300 for y coordinate. So there is one thing you need to take note. Our touchscreen is going to give a script error if, let's say, any of the element drawn on the screen is out of this area. Okay, if you want to have a try, you can try to reduce this x-axis x coordinate to 0. Okay, let's see what happened. So immediately you can see the script error happen because part of the radar is out of the display area. Okay, let us change it back to 60. Okay, acknowledge. All right, so let us try to change this radar to the slightly right hand side of the screen. Okay, change it to 780 for coordinate x, where coordinate y remain as 300. So you can see that now the radar has been shifted to the right hand side. Okay. Okay, why there is a little bit of this gray color things on the screen is exactly as what I've described just now. The working principle for the line function. Okay. Okay. So once we draw it on the screen, it will permanently stay on the screen unless you use some other element, you draw some other thing with black color to cover it up. Okay. So yeah, if let's say I shift this radar slightly downward, you will notice that more gray color or more parts of the radar appear without being wiped out by the rectangle, because our rectangle, I think we draw until 500 only for the y coordinate. Okay, let us shift this thing down slightly to 400. Okay. All right, so you can see that. All right, after I shift this thing back, okay, 300. Okay, right, you can see that this part remains because we do not draw any rectangle to cover up this portion. So just now I believe everybody noticed there is a circle. If we change the y coordinate, there's a circle. Let us reduce it to instead of 300, we reduce it to 250. Okay, so you can see that the circle stay. So let us see which part of the script is actually in charge for this circle. Okay, let us come back to the script. Okay, script ID 103 again to see the circle why it stay if we change the coordinate. Yeah, it is actually because of this 300 was not modified to LDR2. Okay, right, same goes to this. So after we have changed this, the whole radar should appear nicely on the HG touchscreen. Okay, let us save and download it again. Okay, modify data only. Okay, after we have done the download, alright, let's refresh. Okay. Right, let's give 260. $300. If you want to use a program to initialize these two values, of course you can. Okay. Start. Okay, so now if let's say I shift this thing downwards slightly, shift the whole radar downwards slightly to 30. Now the circle should follow as well. Okay, so you can see that this whole circle no longer stay in the position. Let's reduce to 200, let's say. Okay, circle also follow. Alright, so again, this gray color is because of the rectangle is not big enough to override, to cover up this this area. Okay, right, that's all for this tutorial. Okay.